Hello everyone, myself Purva Apte from D.E.S Secondary School, Pune. In the previous session, we studied the different under the lesson chemical reactions and equations. We also studied how to balance a chemical reaction. I hope you must have practiced it at once at home. Now, continuing the same topic, we are going to study some more types of chemical reactions that are taking place in front of us. So let's move on to the PPT. In the last previous session, we had discussed combination reaction, decomposition reaction, double displacement reaction, and displacement reaction. Also, we had studied endothermic reactions. As I said, that it is the reaction where heat is either absorbed from surrounding or is provided continuously from outside. And we also discussed about the example of endothermic reaction. Last time I explained you that how the heat is being absorbed from the surrounding and the reaction is getting completed. Another type we discussed was exothermic reaction. As the name itself suggests, heat is liberated when the products are being formed. So CaO plus H2O gives CaOH twice plus heat, that is liberated. This is called as exothermic reaction. In comparison with endothermic and exothermic reactions, this is a very informative diagram for you all, that in case of exothermic reaction, heat is being given out to the atmosphere, and in case of endothermic, heat is being absorbed. So you can also observe that the reactants that are participating in this reaction for exothermic, they are hotter than the surroundings and they are now going to give out the heat. On the other hand, in endothermic, you will find that the reactants are cooler than the surroundings and heat is getting absorbed to complete the reaction. So this is a comparative study of exothermic and endothermic reaction. Moving further, now we will talk about rate of chemical reaction. Rate means you can say speed of the chemical reaction. As I said that many reactions which are taking place in front of our eyes, they are fast reaction. Some are very slow reactions. There are different factors which affect the speed or the rate of chemical reaction. So we are going to study in detail about various factors, those who affect the rate of chemical reaction. The first factor is nature of the reactant. Nature of reactant, when we are talking about, it is that what type of reactants are reacting together. In the previous lesson, we have studied the reactivity series of metals. According to that, aluminium and zinc, if are working, or in this one kind of reaction, aluminium and zinc are working with hydrochloric acid, hydrogen gas is liberated. But aluminium being more reactive than zinc, we will observe that the reaction with aluminium gets completed faster, whereas with zinc it takes a bit extra time. So here the nature of reactant can affect the rate of chemical reaction. The second point is size of the particles of reactants. Simple example, even though it is not a chemical reaction, you can visualize is that if you take powdered sugar and crystal sugar and try to dissolve it in water, immediately the answer will be that powdered sugar get dissolved faster as compared to the crystalline sugar. Same case happens in case of chemical reactions also. The size of particles affect the rate of chemical reaction. Fine are the particles, faster is the reaction. In the previous session, we studied about the reaction between copper and sulfuric acid. Also, we studied that when copper sulfate, that is CuSO4, and iron react together, at that time, if we use iron particles, the reaction will be faster as compared to the iron nail, because the size of the particle is different, and because of that the rate of chemical reaction affects. Again I repeat, finer are the particles, faster is the reaction. Then the next point is concentration of the reactants. In many reactions we come across, we use dilute acids or concentrated acids. Obviously, more is the concentration of the reactants, faster is the rate of chemical reaction. Again, I repeat, more is the concentration of the reactants, faster is the rate of reaction. Few more factors which affect the chemical reaction are temperature. Temperature of the reactants affect the rate of chemical reaction. More is the temperature, faster is the reaction. If the temperature of the reactants is less, the reaction becomes slow enough. One more very important factor which affect the rate of chemical reaction is catalyst. Catalyst is a substance by its mere presence increases the rate of reaction without causing any chemical change. Again, I repeat that this catalyst is a substance. It is just present in the chemical reaction, but it does not take part in the chemical reaction. But because of its presence, the reaction becomes faster. Here, we have considered the example of 2KClO3 that gives 2KCl plus 3O2. Here, the rate of reaction increases because of the catalyst, that is manganese dioxide, which should be present in this particular system. MnO2 does not take part in the reaction, but its presence make the reaction faster. So, the factors affecting rate of chemical reactions are nature of reactants, size of the particles of reactants, concentration of the reactants, temperature of the reactants, and catalyst. The definition for catalyst is a substance by its mere presence increases the rate of reaction without causing any chemical change. The example which is given here MnO2, that is manganese dioxide, will work as catalyst. It does not take part in the chemical reaction. Now, one more type of reaction that we are going to study is oxidation reaction. Oxidation reaction, again, as the name itself suggests, the reaction in which a reactant combines with oxygen or loses hydrogen to form a product is called oxidation reaction. Example is carbon plus oxygen giving carbon dioxide and 2Mg plus O2 that gives 2MgO, that is magnesium oxide. You must have noticed that both these examples of reaction we have studied in combination reaction as well. Here, these examples we are considering because oxygen is getting combined to form a new product. So, this type of reaction is also included under combination reaction as well as oxidation reaction. Let us repeat the definition for oxidation reaction. It is the reaction in which reactants combine with oxygen or loses hydrogen to form a product. Here you can see magnesium and oxygen reacting together. Oxygen is getting combined and thus the reaction is completed. Another type of reaction is reduction reaction. Reduction reaction is the reaction in which reactants gain hydrogen or lose oxygen to form a product is called a reduction reaction. CuO, that is cupric oxide, plus H2, that is hydrogen, will give Cu plus H2O, that is water. Here you can observe that water is formed. Why? Because from CuO, oxygen is displaced and hydrogen is getting added with it, and it is giving us Cu plus H2O. Here you can study the comparison between reduction and oxidation. In reduction, gain of electrons takes place, and in oxidation, loss of electron is there. And this is how the reaction gets completed. There is combination of oxidation and reduction reaction also, which can be called as redox reaction. That is oxidation reaction plus reduction reaction. Example is 2H2S plus SO2. It gives 3S plus 2H2O. Redox reaction takes place during cellular respiration also. So when you will be studying cellular respiration under Science 2 lessons, there also you will find that this redox reaction is taking place. That is, oxidation and reduction reactions are simultaneously taking place. Here is again some explanation for the redox reaction in cellular respiration. Glucose undergoes oxidation, glucose loses electron and hydrogen, and oxygen gains electron, and thus carbon dioxide and water are formed. This particular diagram will make it more clear that how this redox reaction takes place. Now, very common example of corrosion, which is an example of oxidation reaction. Due to various components in the atmosphere, oxidation of metals takes place, forming oxides of those metals and resulting in their damage is called corrosion. For example, in the rainy season, we observe corrosion of iron takes place. Also, oxide formation of copper utensils. You must have observed, especially in rainy season. Why? Because that time more and more water is available at that particular time. So here the oxidation of copper takes place and cupric oxide, which is greenish in color, is formed, and because of that at home we find that copper utensils get a greenish layer on their surface. Also, we have observed that silver utensils, they also turn blackish due to formation of its oxides. These are the day-to-day examples of oxidation reaction. As I told you initially, that reactions are taking place in front of our eyes. Some are very quick and some are very slow. Corrosion reaction is a slow reaction which takes place in front of your eyes, but you notice it after the result is seen. This is a particular diagram. It explains to you the corrosion of iron. What happens here? Corrosion or rusting. These are the two words which are familiar to us. Now, when rusting of iron is taking place, the different regions on the iron surface become anode and cathode. The portion where iron is oxidized to Fe2 plus, you can observe in the diagram, that is anode region. Here, iron loses electron and becomes Fe2 plus. Now, this released electron flows through the metal surface towards cathode region. Here, they reduce oxygen and water molecule is formed. You can very well observe it in the diagram. Now, this process continues and oxygen is further reduced to form OH minus ions. Further, this Fe2 plus ion from anode migrate and react with OH minus ions, and again Fe3 plus ions are formed. This Fe3 plus ion form hydrated ferrous oxide, which we generally call as rust or corrosion. So this is an example of corrosion. Here you can see the examples of corrosion in iron. This is a very common sight at our homes. Here you can see the nails are completely corroded or rusted. Now this type of material, if it is being used for the construction purpose or any other purpose, obviously it will not give you the proper strength. Also, the next two figures you can very well observe and which are familiar to you, that is Statue of Liberty. It is basically copper made, and because of the corrosion, now it is seen green in color. Otherwise, it is not green in color. So these are the different examples of corrosion of iron and copper which we can experience. Now, one more example of oxidation reaction is rancidity. You can observe the two different colors of oil drops in this particular figure. Fresh oil and rancid oil, which is seen blackish in color. When oil or ghee kept in open comes in contact with air, oxidation takes place, resulting in foul smell and unfit for consumption. This is called as rancidity in foodstuff. When we use old leftover cooking oil for making foodstuff, it is found to have foul odor, which is called as rancidity. If food is cooked in such oil, its taste also changes. When oil or ghee is left aside for a long time, or fried food is left aside for a long time, it undergoes oxidation and becomes rancid. You must have experienced that your mother scolding you for having vada pav on the roadside restaurants, because such oils could be rancid and they are unfit for consumption. So henceforth, be sure that the oil or the ghee should not be kept open for longer time and should not get exposed to air. Here we have some more examples to balance chemical reactions. In the previous session, we have learnt in detail how to balance the chemical reactions. Here we have some more examples for this. First one is Zn plus HCl gives ZnCl2 plus H2. That is, zinc plus hydrochloric acid react together to give zinc chloride and hydrogen. Now here you will observe that there are atoms of reactants and products to both the sides. Zinc is only one to the reactant side and only one on the product side. But if you observe hydrogen and chlorine, you will find that there are two atoms of each on the product side, but only one on the reactant side. So chlorine and hydrogen needs to be balanced. If we add two molecules of hydrochloric acid, then here you can see the reaction becomes Zn plus 2HCl, that is 2 molecules of hydrochloric acid, gives ZnCl2 plus H2. Now if you compare the atoms on the reactant side and the product side, all the reactants and product atoms are properly balanced. Let us consider one more example. Mg plus O2, that is magnesium reacting with oxygen. It gives magnesium oxide. Again, you can find here magnesium is balanced, but oxygen is not balanced. So if we take 2 molecules of oxygen, there will be 4 oxygens on the product side. But what about magnesium? On the other hand, if you think for magnesium, if you take 2 magnesium molecules and 1 oxygen only, then the reaction could be balanced. So here we can say 2 Mg plus O2, it gives 2 MgO, that is 2 molecules of magnesium oxide. Always remember that we can increase the number of molecules that are taking part in the reaction, but the basic formula of any compound should not be changed while balancing the chemical reactions. Here we have one more example. Ag plus HCl, it gives AgCl plus H2. Again, if observed carefully, we will find hydrogen is not balanced on both the sides. But to balance this hydrogen, we should increase the 2 molecules of hydrochloric acid. But in that case, chlorine becomes unstable, chlorine becomes imbalanced, and therefore we need to add one more molecule of AgCl. So the reaction could be like this: 2Ag plus 2HCl. That is, we are taking 2 molecules of Ag and 2 molecules of HCl. That gives us 2 molecules of AgCl plus H2 gas. Another example, one more. Now you are very much habituated to solve the chemical reactions and balance it. MnO2 plus HCl gives MnCl2 plus H2O plus Cl2 gas. Try to solve this and balance this. Here we observe on both the sides, that is reactants and product sides, if you observe, manganese is already balanced, but oxygen is not. Even chlorine is not properly balanced. In case of hydrogen also, we find that there are 2 on the product side, but only 1 atom on the reactant side. So we have to think about all these different atoms that are taking part, and with trial and error method, you can reach to the balanced equation, that is MnO2 plus 4HCl gives MnCl2 plus 2H2O plus Cl2. Now here on the reactant side, we find that there are 4 hydrogens and 4 chlorine. On the product side, you can observe MnCl2, that means 2 chlorine atoms are present over here, and chlorine gas is separately found, that is Cl2. So in all, 4 atoms of chlorine are balanced. Same way for hydrogen, if we are observing 4HCl, that means there are 4 atoms of hydrogen on the reactant side. On the product side, when we write it as 2H2O, that means there are total 4 atoms of hydrogen on the product side. So this is how the reaction is balanced. Let's move to the next example. H2S plus SO2 gives S plus H2O. Very simple reaction you can observe over here, but again it is not balanced one. Now what should be done to balance this particular reaction? Think about whether you could increase the number of molecules of H2S or SO2 could be increased. The answer is 2H2S plus SO2 gives 3S, that is 3 sulfur atoms, plus 2H2O, and thus we find hydrogen, sulfur and oxygen all are properly balanced. Fe plus HCl gives FeCl2 plus H2. If you balance this chemical reaction, you will get Fe plus 2HCl gives FeCl2 plus H2. I would suggest you to every time try to make a table and find out how many atoms are to be balanced and then you will be able to immediately find out that what reactant side or product side, which number of molecule is to be increased. I hope now you have enough practice for the balancing of chemical reactions. So thus we are done with the lesson chemical reactions and equations. I hope now you are very much familiar with the different chemical reactions that are taking place in front of you, in the kitchen as well as around you. And also keep practicing for balancing of the chemical reactions, which is very important for from the point of view of your exams. So keep practicing and read the lesson thoroughly. Thank you so much.